Okay. Blue. Hope nobody's colorblind. So I'm going to call make count again, make another one C2. So I'm going to do this a little more quickly. Right, I'm calling that procedure. So I extend E1. Right? The same as E2 extended E1. E4 extends E1. I make a procedure in here. And that procedure's left bubble is the same as this procedure's left bubble. But its right bubble is different. That makes it a different procedure. Okay, so now you can see why procedures are more than just the lambda expression. The procedure has to remember where it was created. And now we invoke this procedure. So I make a frame E5 with loc 0 extending E4. And I make a procedure, left bubble is the same as that one. Right bubble goes to E5. And now I can say C2 is this procedure. How'd I do? I lined up pretty well. OK. Now, by the way, for the last week or two, I've been drawing this picture. Okay, compare this hand-wavy picture with this detailed picture. I hope they're doing this in HD, widescreen. Here's global, G. C1, C2, and make count are all global variables, along with, plus and minus and cons and all of those things. Here's E1 representing the class, and E3 and E5 representing the instances. Now, there's some extra mechanism like E2 and E4 and a bunch of procedures. And in fact, really what represents the instances is not the frame E3, but this procedure, C1, that points to E3. Because in Scheme, environments are not first-class data. It's procedures that are first-class data. And you have access to environments implicitly by way of those procedures. OK? Does that make sense? OK. Now I'd like to invoke C1. OK? Well, we type this at a Scheme prompt. So it's evaluated in the global environment. So we recognize it as a procedure call because it has parentheses and it doesn't have a keyword here. And then we evaluate the C1 by looking it up in the global environment, and we follow this yellow arrow over to this procedure. Okay? So just to remind you, I'm going to draw a little C1 next to here. But this isn't part of the diagram. Maybe I shouldn't do it. Because I don't want you to think that the name in here is in the procedure. This has the name C1 only because there's a binding C1 back in the global environment that points to it. It could have some other name in some other frame. It could be called foo in this frame. Okay? But this is the procedure C1, and we're going to call it, and it doesn't have any arguments. So I'm going to make a frame, E6, that extends E3. What was the current environment for this procedure call? It was G. It was the global environment because I typed it at a scheme prompt. But we're not going to extend G. We're going to extend E3. Why? Because that's the rule about right bubbles. You extend the environment with the right bubble. That's that side of the brain. Left side of the brain, oh, look. We need to have access to the instance variables and to the class variables and to the global variables. And we do. Okay, so this worked out the way we wanted it to. Okay, so now I can evaluate the body of this procedure. The body says, which comes first? Set bang loc plus loc1. Okay, so first I have to evaluate plus loc1. Well, it's a list, i.e. it's in parentheses, and its first element isn't a keyword, namely if, lambda, con, define, and so on. It isn't one of those. So this is a procedure call. I recursively evaluate the subexpressions. So let's evaluate plus. It's a symbol. How do we evaluate symbols? We look them up in the current environment. What is the current environment? E6. Is there a binding for loc in E6? No. So I follow the arrow. Is there a binding for loc in E3? Yes. So this is the one I want. What's its value? 0. Oh, I'm sorry. I'm looking for plus. Ugh, I'm getting ahead of myself. I'm looking for plus in E6. Is there a plus in E6? No. Is there a plus in E3? No. Plus in E2? No. Plus in E1? No. Plus in G? Oh, why, yes, there is. Plus is a primitive procedure, whatever those look like. Hand wave. Primitives work by magic. Okay, so plus, primitive procedure. Now I have to evaluate loc. And now I say, is loc here? No. Is loc here? Yes, it is. Its value is 0. How about 1? Do I look that up in the environment? Who says I look up 1 in the environment? Who says I don't look up 1 in the environment? Right. 1 is self-evaluating. It's a number. So its value doesn't depend on what environment we're in. It's always 1. So now I have the actual argument values, 0 and 1. And I have the procedure, that primitive over there. And I call it, by magic, with the arguments 0 and 1. It gives me the answer 1. Now I'm back to that set bang. It says set bang loc. So I have to do the same thing, looking for the symbol loc in the current environment. Is it bound in E6? No. Is it bound in E3? Yes. So this is the binding I'm going to change. I change loc to 1. OK, we're not finished with the body yet. There's another set bang for glob. So I have to evaluate the second argument to set bang. It's a procedure call. First subexpression is plus sign. I look it up. Boom, 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 boom. There it is. It's the addition primitive. Now I have to look up glob. Is it here? No, no, no. Yes, value 0. And I don't have to look up 1. It's self-evaluating. So I call plus with 0 and 1. I get 1. Now I have to look for glob again to do the set bang. Is it here? No, no, no. Yes. So I change this binding to 1. And now I return list loc glob. I have to look up list, which I find in the global environment. It's a primitive procedure. And I have to look up loc and glob. They're 1 and 1. So I make the list containing 1 and 1, and that's what it returns.